Hello everyone. In the last session, we have discussed about the moving charges and magnetism as well as magnetism and matters. So in that chapter, we have discussed that using a current, we can produce the magnetic field. Even though we have discussed where there is a moving charges, there will be a magnetic field around it. This concept was first introduced by Oersted. Yes, his name is Oersted, even though we have discussed the experiment done by the Oersted. Is it clear? So like that only, today I am going to discuss a new concept, that is what? Electromagnetic induction. Electromagnetic induction. So in this chapter, we will discuss how the current can be produced using the magnetic field. How the current can be produced using the magnetic field. Is it possible? If the current can produce the magnetic field, then is it possible to produce the current using the magnetic field? Yes. If the current can be produced, magnetic field. Using current we can produce the magnetic field. Like that only, is it possible to produce the current using magnetic field? Yes, it is possible. So how it is? In the year of 1831, his name is Michael Faraday. His name is Michael Faraday. He proposed the concept called electromagnetic induction. It means he said that we can produce the current using the magnetic field lines, or else you can call it as your magnetic flux. Is it? Then how it is possible? He conducted so many experiments related to that one, and he concluded that we can produce the current using magnetic flux, using magnetic field lines also. Is it? So let us see first, what is that electromagnetic induction? Electromagnetic induction. In this word only, we can see two words, that is electro and next one is magnetic. There is a relation between the electric current as well as magnetic field, or else you can call it as magnets. Then what is exactly meant by electromagnetic induction? Let us see now. So here, the phenomenon of production of EMF. Yes, the phenomenon of production of EMF in the conductor, and the magnetic flux linked with the conductor changes. When the magnetic flux linked with the conductor changes. Firstly, let us see what is meant by EMF. I think you know about the EMF, electromotive force. Electromotive force. Here, the phenomenon of production of EMF. Here, we can produce the EMF in the conductor. That is what the electromotive force. How that? Using any other energies, we can produce the electric current. That process is nothing but the EMF ಅಂತ ಕರೀತೀವಿ. ಯಾವುದೋ ಒಂದು ಎನರ್ಜಿ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಎಲೆಕ್ಟ್ರಿಕ್ ಕರೆಂಟ್ ಅನ್ನು ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದು. ಹೌದಾ? We can produce the electric current using other non-electric sources. Using the non-electric sources, we can produce the electric current. That process is nothing but the EMF ಅಂತ ಕರೀತೀವಿ, electromotive force ಅಂತ ಕರೀತೀವಿ. Is it? So like that only, the phenomenon of production of EMF in the conductor, when the magnetic flux linked with the conductor changes. Here, other non-electric source in the sense, that is what? Magnetic flux. ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ದಿಂದ ಕರೆಂಟ್ ಅನ್ನು ಉತ್ಪಾದನೆ ಮಾಡ್ತೀವಿ. ದಟ್ ಈಸ್ ವಾಟ್ EMF ಅಂತ ತಗೋತೀವಿ. EMF is nothing but the production of electric current using the non-electric sources. Here the non-electric source means magnetic flux ಅಂತ ಕರೀತೀವಿ. The phenomenon of production of EMF in the conductor when the magnetic flux linked with the conductor changes. Here the magnetic flux will change continuously. The magnetic flux will change continuously. So due to that, we can produce the EMF in the conductor. So we got to know about the EMF. Then what is meant by magnetic flux? In the last session only we have discussed about the magnetic flux. In the magnetism matters we have discussed about the magnetic flux. So what is magnetic flux? Let us write here. Magnetic flux. Magnetic flux. So what is that magnetic flux? Magnetic flux ಅಂದ್ರೆ ಏನು ಅಂತ ಕರಿತೀವಿ? Yes, the number of magnetic field lines passing through any area. The number of magnetic field lines. The number of magnetic field lines. Magnetic field lines passing through any area is called magnetic flux. It is called magnetic flux. So ಇದನ್ನು ಮತ್ತೊಂದು ಥರನೂ ಡಿಫೈನ್ ಮಾಡಬಹುದು. ಏನಂತ ಹೇಳಿ, the number of magnetic field lines passing through any area, or else you can also define as the magnetic flux through any surface is defined as the total number of magnetic field lines of force. The total number of magnetic field lines of force passing through any area andru neditare. Any area is called magnetic flux. This is what the magnetic flux. Let us write the expression for magnetic flux here. What is that magnetic flux? First, let us take an area. This is what the one area anta ankodu, or else you can take any substance. Here it is. This is what the area. ಈ area ಏನು ಮಾಡ್ತೀನಿ ಅಂದ್ರೆ I am going to keep that area or any substance inside the uniform magnetic field line. So these are the magnetic field lines. These are the magnetic field lines. So I am going to keep that substance inside that uniform magnetic field lines. At that time, here you can see there are two magnetic field lines are passing through this area. Yes, is it clear? So that is what the magnetic flux anta kariತೀವಿ. Is it clear? So here this area is A and here it is B. B, what is meant by B? The magnetic field lines. A is the area of the substance. This area. Here is the area. Okay. Here there is an angle between this area and the magnetic field lines. That will be theta. Here the magnetic field lines are passing through the area will be normally. Normal cross section you can also call it as perpendicular, and it is depends upon the situation. You kept that substance inside that uniform magnetic field lines. Is it clear? One area, this is what the magnetic field line B, and this is what the area. Here the magnetic field lines are passing through the substance with an angle theta. That is what the area A anta kariತೀವಿ. There is an angle between the area of that substance and the magnetic field line B. Is it clear? ಅರ್ಥ ಆಗ್ತದೆ ನೋಡಬಹುದು. There is an angle between the uniform magnetic field lines and the substance area which is kept inside that uniform magnetic field lines. There is an angle between these two. So flux can be written as it is the product of B and A with a cos theta. Why it is the cos theta? Adjacent side divided by hypotenuse. There is an angle between these two. That's why we will use cos theta. Here we can also write it as B, vector B dot vector A. Here it is the dot product of two vectors. And this is what the expression for magnetic flux. ಅರ್ಥ ಆಗ್ತದನ್ನ ಹೇಳೋದು? Yes. So what is magnetic flux? The number of magnetic field lines passing through any area. Here it is the magnetic field lines. The magnetic field lines which are passing through this substance with an angle theta. Is it clear? So here the B is the magnetic field line, A is the area. There is an angle between these two. That is what the magnetic flux. Magnetic flux. So magnetic flux can be written as B into A into cos theta. Why I am going to write here cos theta? Here adjacent side divided by hypotenuse. That is what the cos theta. Dot product of two vector is nothing but the cos theta. Is it clear? And we can see that there is a dot product of two vector. Then flux will be scalar quantity. Scalar quantity. So this is what the magnetic flux. So now we got to know about what is meant by electromagnetic induction. The phenomenon of production of EMF. The phenomenon of production of EMF in the conductor when the magnetic flux linked with the coil changes. Linked with the conductor changes. Is it clear? Here the magnetic flux should be continuously changes. It should change. ಹೌದಾ? ಅವಾಗ ಏನಾಗ್ತದಪ್ಪ ಅಂತರ ನಮಗ EMF ದೊರಕುತ್ತದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಒಳಗ. And this is the magnetic flux. This is the magnetic flux. Now let us see what are the special cases of those flux. Flux special cases ನೋಡೋಣ. Yes? That's okay. Special cases. And the flux becomes maximum and that flux becomes minimum. Number one, if theta is equal to 90 degree. If theta is equal to 90 degree, it means the substance is exactly perpendicular to the substance area. I'm going to say that the substance area is perpendicular to the direction of magnetic field. At that time, flux becomes 0. Flux ಏನಾಗ್ತದೆ? 0 ಆಗ್ತದೆ. Yes, cos 90 ಏನಾಗ್ತದೆ? 0. Is it clear? ಹೆಂಗ್ 90 ಆಗ್ತದೆ? Yes, ನೋಡ್ರಿ. Let us see. This is for the magnetic field line. This is what the magnetic field line. Here, a substance is kept like this. I'm going to say that the area of the substance, let us imagine this is what the area, this is area A. One more thing, the substance, if the substance is like this, on the substance its area is in this direction. If the area's direction or substance is in this direction, its area is in this direction, then what will happen? There are two diagrams. Can you say which one is 90 degree and which one is 0 degree? ಯಾರಿಗಾರು ಹೇಳಕ್ ಸಾಧ್ಯದ ಇಲ್ರಿ? ಹೌದಾ? ಒನ್ ಥಿಂಗ್ ನಾವು ಏನು ಹೇಳಬಹುದಪ್ಪ ಅಂತಾರೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಒಳಗ theta is equal to 90 degree ಯಾವಾಗ ಇರ್ತದಪ್ಪ ಅಂದ್ರೆ when B and A are exactly perpendicular to each other. ಇನ್ನೊಂದು ಏನು ಹೇಳ್ತೀವಪ್ಪ ಅಂತಾರೆ when the magnetic field lines are parallel to the area of the substance ಇದ್ದಾಗ theta is equal to ಏನಾಗ್ತದ ರೀ? 0 ಆಗ್ತದ. ಹಂಗಂದ್ರೆ parallel ಯಾವಾಗ ಇರ್ತದ ರೀ? ಆಮೇಲೆ perpendicular ಯಾವಾಗ ಇರ್ತದ ರೀ? Yes, ನೋಡ್ರಿ ಈ ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಂಡಿದ್ದೀನಿ ನಾನು. Let us imagine this substance only. This substance area is this one. Our substance ಏನು ಮಾಡಿದೀನಿ? ಈ ತರ ಇಟ್ಟಿದ್ದೀನಿ. Area is in this direction and uniform magnetic field lines are traveling in this direction and both are exactly perpendicular to each other. So at this point flux will be 0. Yaka the magnetic field lines are traveling from the magnetic field lines are passing through the substance, but the area of the substances and the magnetic field lines are exactly perpendicular to each other. Area direction ಈ ಕಡೆ ಅದ, ಸಬ್ಸ್ಟೆನ್ಸ್ ಏನದ ಈ ಕಡೆ ಅದ. ನೋಡ್ರಿ ಈ ಏರಿಯಾ ಮೇಲೆ ಯಾವುದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ ಪಾಸ್ ಆಗಿ ಹೋಗೋದಿಲ್ರಿ. ಓನ್ಲಿ ಏರಿಯಾ ಡೈರೆಕ್ಷನ್ ಈ ಕಡೆ ಅದ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಈ ಕಡೆ ಹೋಗಿದ್ದಾರೆ, ಈ ಕಡೆ ಹೋಗಿದ್ದಾರೆ. ಬೋತ್ ಆರ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಈಚ್ ಅದರ್. ದೆನ್ theta becomes 90 degree. If cos theta is 90 degree, then flux will be 0. It means the magnetic field lines are not passing through the substance that will be normally. It means the magnetic field lines are perpendicular to the area of the substance. Here it is. The magnetic field lines are perpendicular to the area of the substance. In the first case. In second case, ಇದನ್ನ ನಾನು substance ಏನು ಮಾಡಿದೀನಿ, ಈ ತರ ಇಟ್ಟಿದ್ದೀನಿ. Here, all the magnetic field lines are passing through the substance as well as area of the substance. ಅರ್ಥ ಆಗ್ತದನ ಹೇಳೋದು? ಅದನ್ನ substance ಈ ತರ ಇಟ್ಟಿದ್ದೀನಿ ನಾನು. All the magnetic field lines are passing through the substance as well as all the magnetic field lines are passing through the substance as well as area of the substance. It means this is what the area and the magnetic field lines are passing through that substance, and both are exactly parallel to each other. Or else you can say that area of the substance as well as the magnetic field lines directions are exactly same. Is it? Here the area of the substance as well as the direction of the magnetic field lines are exactly parallel to each other. It means theta is equal to ಏನಾಗ್ತದೆ 0 ಆಗ್ತದೆ. It means most of the magnetic field lines are travel through this substance. Then flux will be maximum. Flux ಏನಾಗ್ತದೆ maximum ಆಗ್ತದೆ. Is it clear? And this is what the flux. Yes, this is what the flux. Okay. Next is magnetic flux density. What is magnetic flux density? Magnetic flux density. What is that magnetic flux density? So number of magnetic field lines per unit area. The magnetic flux per unit area is nothing but magnetic flux density ಅಂತ ಕರಿತೀವಿ. Magnetic flux per unit area. Magnetic flux per unit area is called magnetic flux density. Magnetic flux per unit area of the substance is called magnetic flux density. Then what will be the unit of magnetic flux? ಏನಾಗಿರ್ತದೆ magnetic flux unit? So here, right here, so SI unit of magnetic flux. Magnetic flux is Weber. In CGS system of the magnetic flux ಏನಾಗಿರ್ತದಪ್ಪ Maxwell, or else you can say it as 1 Maxwell is equal to 10 to the power minus 8 Weber. This is what the CGS unit of magnetic flux. Is it clear? Now we have discussed about the electromagnetic induction, definition of electromagnetic induction, as well as what is meant by EMF and what is electromagnetic flux, and expression for magnetic flux, and what is the expression for magnetic flux. That is what pi is equal to PA cos theta, or you can write it as B dot A ಅಂತ ಕರಿತೀವಿ. Like that only special cases of the magnetic flux ಅನ್ನು discussion ಮಾಡ್ಕೊಂಡ್ವಿ. Next is we have discussed magnetic flux density, magnetic flux per unit area of the substance ಅಂತ ಹೇಳ್ತೀವಿ, and the SI unit of magnetic flux is Weber. And then CGS system of the magnetic flux is Maxwell, or it's 1 Maxwell is equal to 10 to the power minus 8 vector. Now let us see how the Maxwell is proposed this concept. What are those experiments held by the Faraday? Is it clear? Okay. So one more thing I have forgotten to discuss with you. So this electromagnetic induction, using the magnetic flux only we can produce the EMF in the conductor. Is it? So what are the instruments? Daily life instruments. Now daily life for ಎಲ್ಲಿ use ಮಾಡ್ತೀವಿ on the basis of Faraday principle. What are the devices which works on those principle? That principle was Faraday principle ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾವ್ಯಾವಪ್ಪ ಅಂದ್ರೆ ಜನರೇಟರ್ ತಗೋತೀವಿ, ಗ್ರೈಂಡರ್ ತಗೋತೀವಿ, ಅಥವಾ ಟ್ರಾನ್ಸ್ಫಾರ್ಮರ್ ತಗೋತೀವಿ. Some devices are there which are totally works on the principle called Faraday's principle. Is it clear? ಹೌದಾ? ನಾನು ಹೇಳೋದು ಅರ್ಥ ಆಗ್ತದೆ ಹೇಳೋದು? Okay. Now let us see the experiments held by the Faraday. The experiments held by the Faraday or you can say that there are some demonstrations which are held by the Faraday to explain about electromagnetic induction. The first one is coil and magnet experiment. Coil and magnet experiment. And second one is coil and coil experiment. Another one is coil and that is what coil experiment, and second one is coil experiment, and third one is relative motion of the carrying conductor coil inducing the EMF of the conducting coil. And this is also the coil experiment. There is a slightly change in that. So let us see what is first one, coil and magnet, to demonstrate that electromagnetic induction. First, he took a coil which is connected to the galvanometer. Is it? Now he took a magnet which is having north and south pole. That is what the bar magnet. Okay. See here. Let us see first experiment. That is what the coil magnet experiment. The relation between the coil and the magnets. They may ask for 2 marks or 3 marks. Yes. Write down any one demonstration of the Faraday experiment and the Kelvin. The first one is coil and magnet. He took a coil and that coil is connected to a galvanometer. That coil is closed coil and that coil is connected to a galvanometer, and he took a magnet which is kept near to the coil. So in first case, if both are at steady position, or else you can say that both are at a constant state, ಯಾವುದು ಮೂವ್ ಆಗತ್ತಿಲ್ಲ, ಎರಡು ಒಂದೇ ಜಾಗದಲ್ಲಿ ನಿಂತಿದಾವ. At that point we can see that there is no current is produced in that coil in the steady state ಒಳಗದ. Next ಏನು ಮಾಡ್ತಾನಪ್ಪ ಅಂತಂದ್ರೆ he starts moving that bar magnet closer to the coil. Is it? ನಾನು ಅರ್ಥ ಆಗ್ತದೆ. He starts moving that bar magnet closer to the coil. As we know that a bar magnet can produce the magnetic field. Yes, a bar magnet can produce the magnetic field lines, which has the magnetic field lines. By bringing that bar magnet near to the coil, so at that point the magnetic field lines starts entering the coil. Yes, is it clear? ನಾನು ಹೇಳೋದು ಅರ್ಥ ಆಗ್ತದ್ರಿ? ಇದು magnetic field lines ಹೆಂಗಿರ್ತಾವ್ರಿ? ಈ ತರ ಇರ್ತಾವ. So at that point, while bringing that bar magnet near to the coil, here at that point that galvanometer starts deflection in one direction. ಅರ್ಥ ಆಗ್ತದ ಹೇಳೋದು? ನೋಡ್ರಿ, ಇದೊಂದು ಕಾಯಿಲ್ ಅನ್ಕೊಳ್ರಿ. ಕಾಯಿಲ್ ಒಳಗ ಒಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ತಗೊಂಡಾರ. ಆ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಸಮೀಪ ತಂದ ತಕ್ಷಣ the magnetic field lines are starts entering the coil. Here the magnetic field lines are starts entering the coil. At that time, that galvanometer will show deflection in one direction. Is it clear? And at that point, if you bring that bar magnet closer to the coil and you stop it at a particular point without touching that coil, then at that time that galvanometer comes to its original state only. ಅರ್ಥ ಆಗ್ತದೆ ಹೇಳೋದು? ಇದು ಒಂದ್ ವೇಳೆ ಮೂವ್ ಆಗಕತ್ತಿತ್ತಪ್ಪ ಅಂದ್ರೆ ಅಷ್ಟೇ ಏನಾಗ್ತದ್ರಿ, ಇಟ್ ಸ್ಟಾರ್ಟ್ಸ್ ಡಿಫ್ಲೆಕ್ಷನ್. ಇಟ್ ಸ್ಟಾರ್ಟ್ ಡಿಫ್ಲೆಕ್ಟಿಂಗ್ ಇನ್ ಒನ್ ಡೈರೆಕ್ಷನ್. ಒಂದ್ ವೇಳೆ ಬಂದ್ ಸಮೀಪ ನಿಂತಪ್ಪ ಅಂತಂದ್ರ galvanometer ಏನಾಗ್ತದ್ರಿ, ಝೀರೋ ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸ್ತದ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಓಕೆ. ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕೇಸ್, ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾನಪ್ಪ ಅಂದ್ರೆ ಅಗೇನ್ the bar magnet, he starts moving that bar magnet in backward direction. First ಏನಾಗಿತ್ತು ಹೇಳ್ರಿ, ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಮಾಡತ್ತಿದ್ದ. ಸೆಕೆಂಡ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಮೂವ್ ಆಗತ್ತಿತ್ತ. At that time also that galvanometer starts deflecting, but opposite to the direction of first one. ಆಗಲೇ ಈ ಕಡೆ ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗತ್ತಿತ್ತ, ನೆಕ್ಸ್ಟ್ ಏನಾಗತ್ತೈತ್ರಿ, ಈ ಕಡೆ ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗತ್ತಿತ್ತ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ನಾ ಹೇಳೋದು ಅರ್ಥ ಆಗ್ತದ್ರಿ? ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾನ, ಒಂದು ನಾರ್ತ್ ಪೋಲ್ ತಗೊಳ್ತಾನ. he starts moving that bar magnet towards the coil. At that time that galvanometer will show some deflection in one direction, and suddenly he stopped that bar magnet closer to the coil. At that time that galvanometer will come to the rest position. Again he starts moving that bar magnet in backward direction. At that time that galvanometer will show deflection, but opposite to the direction of first one. Is it clear? Now he changed the poles of the magnet. He took south pole at this direction, at this point. Again he starts moving the bar magnet closer to the coil. At this point you have to see that the direction of the magnetic field lines are changing. Direction ಏನಾಗಿತ್ತು, ನಾರ್ತ್ ಟು ಸೌತ್ ಈ ಕಡೆ ಬರತ್ತಲ್ಲ, ಆಗಲೇ ಏನಾಗಿತ್ತು, ಈ ಕಡೆ ಆ ಕಡೆ ಬರ್ತದೆ. So at that time if he starts moving towards the coil, at that time again the galvanometer will show the deflection, but opposite to the north pole. North pole ಇದ್ದಾಗ ಏನ್ ಡೈರೆಕ್ಷನ್ ಇತ್ತು, ಈ ಕಡೆ ಇತ್ತಲ್ಲ ಫಸ್ಟ್. ಈಗ ಸೌತ್ ಪೋಲ್ ಹಾಕಿದ ತಕ್ಷಣ ಫಸ್ಟ್ ಏನಾಗ್ತದ್ರಿ, ಈ ಕಡೆ ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗ್ತದೆ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾನಪ್ಪ ಅಂತಾರ, again he starts moving that bar magnet in backward direction. Again the galvanometer will show some deflection. It means only that galvanometer will show the deflection only when a small current is passed through the coil. Is it clear? We know that when the galvanometer will show deflection, if the current is passing through the galvanometer, then it will show the deflection. But here there is no current, only the magnet is used to only the magnet and coils are there. If the bar magnet is moving towards the coil, that galvanometer shows the deflection. It means something is there. Something is there in the sense that magnetic field lines are entering the coil. While entering the magnetic field lines through the coil, it produces the current. At that time, galvanometer will show the deflection. Is it clear? Then he concluded that we can produce the current using the magnetic field lines. Magnetic field lines, these are the magnetic field lines. This is what the first experiment held by the Faraday. And second one is coil, or you can say it as coil and battery. Coil and battery. At this point, he took a coil, same coil, that is closed coil, which is connected to a galvanometer, and he took a wood, or else you can say it as any material which is you can say it as insulator ಅಂತ ಹೇಳ್ಬೋದು. ನೀವು ಒಂದು ಕಟ್ಟಿಗೆ ತಗೊಂಡ ಅನ್ಕೊಳ್ಳೋದು, ಒಂದು ಪೈಪ್ ತಗೊಂಡ ಅನ್ಕೊಳ್ಳೋದು, ಪ್ಲಾಸ್ಟಿಕ್ ತಗೊಂಡ ಅನ್ಕೊಳ್ಳೋದು. He took a plastic or else you can say there is any wooden one, and these are it is the wire which is wounded on that wood, and both the ends of the coils are connected to the battery. Both the ends are connected to the battery. It is just like just looks like a solenoid. Here it is. This is what the wood. This coil is wounded on that wood, and both the ends of the coils are connected to the battery. It means a current is passing through the coil. Is it clear? A current is passing through the coil. Okay. Now let us see. Again, he did the same. As we know that if the current is passing through the coil, it produces the magnetic field. It produces the magnetic field around the wire. We have discussed about this concept in the moving charges and magnetism. Where there is a moving charges, there is a magnetic field around it. So like that only, here the battery is connected to the wire. The current is flowing through that wire. Here coil looks like a solenoid. At that point, that solenoid acts like a bar magnet. Obviously, the magnetic field lines will travel from one end to another end. They will just act like a solenoid. So again, he did the experiment. He starts moving that coil towards the coil. At that point, the galvanometer starts deflecting in one direction. That galvanometer starts deflecting in one direction, and he bring that, or else you can say that he brought that coil near to the coil. He brought this coil near to this coil, and he stopped. At that point, that galvanometer will come to the rest at 0. It means there is no current flowing through the galvanometer when both are at steady state. When both are at steady state. One nilisippa, ಎರಡು stop adu. At point ಏನಾಗ್ತಿಪ್ಪ galvanometer 0 ತೋರಿಸ್ತದ. Again, he moved that solenoid. You can say that solenoid, or else you can say that this coil which is connected to the battery in backward direction. At that time, again the galvanometer will show deflection, but in opposite direction. Then he concluded that there is a current inside that coil. We can produce the current inside the coil. Is it clear? ಅರ್ಥ ಆಗ್ತದೆ ಹೇಳೋದು? ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟ್ ತಗೊಂಡಾನ, ಇಲ್ಲಿ solenoid ತಗೊಂಡಾನ, which is connected to the battery. While passing the current through the solenoid, that solenoid acts like a bar magnet. Is it clear? Hoga deflection ತೋರಿಸಿದ್ವಿ, but opposite to the direction of first one. And this is what the second experiment. That is what the coil and battery can ತಗೋತೀವಿ. In next note, in third experiment, in this concept also, in this demonstration also, he concluded that we can produce the current inside the coil using the magnetic field lines. Okay. Now he took two coils which are wounded on a wooden bar. Is it? He took two coils. One is connected to the galvanometer, and he took another coil which is wounded on that wooden, and it is connected to the battery as well as a tapping key. Tapping key in the sense, while tapping that point, the current will pass through the coil. Okay. Now let us see that how he demonstrated that coil experiment. There are two coils. One is connected to the galvanometer, and another one is connected to the battery as well as tapping key. Here, he is not going to move any coils. He is not going to move any coils. He kept at a steady state only. ಎರಡು ಒಂದು steady state ಒಳಗಡೆ ಇಟ್ಟಿದ್ದಾನವ. Here, this coil is connected to the battery as well as key. While tapping this key, while connecting this key, a current will pass through the coil. At that time, it produces the magnetic field around the coil. Is it? Those magnetic field lines will travel through this coil also. This coil also. Is it clear? while tapping the key, the current will pass through the coil and it produces the magnetic field. It produces the magnetic field around it, and those magnetic field lines are passed through this coil. At that time, the galvanometer will show deflection. The galvanometer will show deflection. Is it clear? Na heludu artha agutade na helodu? Okay. While doing that, or now tap model bit takshana, the current will starts flowing through the coil. Then magnetic field lines will be gone. ಹೋಗಿಬಿಟ್ಟಿರ್ತಾವ. ಹಂಗಾದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ಈ galvanometer ಒಳಗೆ ಡಿಫ್ಲೆಕ್ಷನ್ ಆಗುತ್ತೆ. ಏನೂ ಆಗಕ್ಕೆ ಸಾಧ್ಯ ಇಲ್ಲ. ಇಲ್ಲಿ ಎರಡು ಕಡೆ ಮೂವ್ ಮಾಡಿದ್ದ, ಇಲ್ಲಿ ಎರಡು ಕಡೆ ಏನಾಗಿಪ್ಪ ಅಂದ್ರ ನಿಂತಾವ, ಸ್ಟಡಿ ಸ್ಟೇಟ್ ಒಳಗ. ಇಲ್ಲಿ ಬರೀ ಬ್ಯಾಟರಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದ ಟ್ಯಾಪ್ ಮಾಡ್ತೀವಿ. ಟ್ಯಾಪ್ ಮಾಡಿದ ತಕ್ಷಣ it produces the current through the coil and it produces the magnetic field around it, and those magnetic field lines are, while passing through the coil, it produces the current. Is it clear? At that time, that galvanometer will show the deflection. Only when that galvanometer will show deflection, only when if the current is passed through the galvanometer. So these are the three demonstrations, and these three demonstrations are very important. ಬಹಳಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಅದಾವ. ದೇ ಮೇ ಆಸ್ಕ್ ಫಾರ್ 3 ಮಾರ್ಕ್. ಯಾವ್ದಾದ್ರು ಒಂದು ಕೇಳ್ತಾರೆ ಇದ್ರೊಳಗ. ಅರ್ಥ ಆಗ್ತದೆ ನಾ ಹೇಳೋದು? And this is about the Faraday's experiment. These are the Faraday's experiment. You can say that experiment or else you can say that demonstrations. ನೋಡ್ರಿ, ಬ್ರೀಫ್ ಆಗಿ ಫಸ್ಟ್ here ಮೊದಲಿಂದ ಮತ್ತೊಮ್ಮೆ ಹೇಳ್ತೀನಿ. ಒಂದು ಕಾಯಿಲ್ ತಗೋತಾನ, ಒಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ತಗೋತಾನ. ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅನ್ನ ಸಮೀಪ ತಂದ ತಕ್ಷಣ ಏನಾಗ್ತದ್ರಿ, ಕಾಯಿಲ್ ಒಳಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಂಟರ್ ಆಗ್ತಾವ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಂಟರ್ ಆದ ತಕ್ಷಣ ಈ ಕಾಯಿಲ್ ಏನ್ ಮಾಡ್ತದ್ರಿ, ಇಟ್ ಪ್ರೊಡ್ಯೂಸಸ್ ದಿ ಕರೆಂಟ್. ಹೆಂಗ್ ಗೊತ್ತಾಗ್ತದ್ರಿ? ದಿಸ್ galvanometer is connected to the coil. At that time, coil will give the deflection. ಈ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ದೂರ ಸರಿಸಿದ ತಕ್ಷಣ ಏನಾಗ್ತದ್ರಿ, galvanometer ಏನಾಗ್ತದ್ರಿ, ಡಿಫ್ಲೆಕ್ಷನ್ ತೋರಿಸದ, ಬಟ್ ಅಪೋಸಿಟ್ ಟು ದಿ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಫಸ್ಟ್ ಒನ್. In second case, what he took a coil and he took another coil which is wounded on the wooden bar, and that coil is connected to the battery and this coil connected to the galvanometer. Here, while passing the current through the coil, it produces the magnetic field, and those magnetic field lines are while entering the coil, it produces the current. That current is noticed by the galvanometer. Same, ಸಮೀಪ ಬಂದ ತಕ್ಷಣ magnetic field line enter ಆಗ್ತಾವ, galvanometer deflection ತೋರಿಸ್ತದ. ದೂರ ಸರಿಸಿದ ತಕ್ಷಣ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಏನಾಗ್ತದ್ರಿ, ಪಾಸ್ ಆಗ್ತಾವ, ಬಟ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ ಹೋಗ್ತಿರ್ತಾವ. At that time also it shows the galvanometer deflection, but opposite to the first one. In third ಒಳಗೆ ಏನಾಗ್ತಪ್ಪ ಅಂದ್ರೆ ಎರಡು ಕಾಯಿಲ್ ತಗೊಂಡ್ರ, one is connected to the galvanometer, another one is connected to the battery as well as key. So tap ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗ್ತದಪ್ಪ ಅಂದ್ರೆ it produces the current as well as it produces the magnetic field lines, and those magnetic field lines while entering this coil, it produces the current through the coil. This is what the this is what the demonstration of Faraday's. So then what is the conclusion of this experiment? Conclusion ಏನ್ ಬರ್ತದಪ್ಪ ಅಂತಾರೆ, whenever there is a relative motion between the coil and the bar magnet, coil and the battery, at that time it produces the current.